Welcome back to the large greenhouse. We've got our exhausting done. We did all the pipe work, and I'll show outside what that looks like. It was fairly easy once I acquired the right pipe to actually complete this job. We also picked up a ton of bricks. We've got over 150 bricks in about one day, and we found all these for 50 cents a piece or less on our local marketplace. So finding all those scores online are amazing to us. We're able to get all this stuff much cheaper. We got a bunch of solid brick, a bunch of old brick, a bunch of new brick, but it's all brick the same. We wanted to make sure we used clay to store the heat around this stove. So let's check this out real quick. We've got at least 2 inches of dead space. We had to cut basically an 8-inch gap all the way around, maybe 9-inch gap, because this is 6-inch piping. So I drilled some holes and I basically cut all of that out, and then I put my plating up there. You can see I got gasket maker on that there. And then coming out back, we've got a nice gap where this comes out all the way around. Keep it nice and safe, and that's metal there. So we ran it out, ran it up, and I gave it a nice extension to go up. Nice and solid, secure. Built a little bracket, got the clamp holding her on. Nice cap to finish it off. And it's a very windy day, and all of that exhaust is rolling right out for it. It's not back burning, it's not blowing any smoke in here. You can see that it is not smoky in this greenhouse, so that is a plus for us. We did something right. This is the first time I've ever actually routed a stovepipe to get out and up. So I wasn't sure if my short stack here, vertical rise, and then that long horizontal was going to make a difference, but it is drawing very, very well. Got a few pieces of log in there, got wood chips burning, and we'll get some temps from all of this here. Just want to see what kind of temps we're holding after about an hour of this fire being burning. Holy cow, got 180, 160, 130 on just the bricks here. We're just shining it on the inside of the bricks, and after about an hour, the outside of the bricks, let's see down at the ground level here. So we were sitting about 46 degrees. So the greenhouse was 45 degrees this morning from our John Payne heating, holding those temps. As soon as the sun came up, even behind the clouds, it started cycling, and you can see in here it's just kind of pulsing. And I've got my John Payne air blowing actually through these brick holes, and it blows it out the other side as it pulses. So we're using our John Payne heated air and solar power to basically push that 50, 60, 70. I'm not even sure what the temp is on the air coming in anymore. It's blowing it through those bricks as I lined them all up, so everything can come right out of the holes there, and it's a nice straight shot. So jumping down to the front here, you can see 2 bricks deep. It's only 50 degrees, about 50 degrees on the front side. So I got my gloves drying here. A lot of glare there. So these bricks right here where my gloves are about 100 degrees. I might move those over a bit. They were kind of steaming. So the actual stove itself, it's registering like almost 500 degrees in certain spots. Stove top, we've got our actual stack, and we had placed a bunch of bricks on this back wall, and we threw up this piece of fireboard here. So I have an extra little piece left, just what I believe to be styrofoam in a bunch of concrete with a little bit of meshing in there just to kind of hold it together. And that board, before we got our bricks up, was holding very good temperatures. Now that we've got these bricks up, you can see the further away, the lower the temp. See on the outside of the bricks here, about 60, 70 degrees. 90 degree bricks, and then right next to the stack, the bricks are 160, 180, and then we'll kind of scoot along the bricks there and show how that kind of dissipates. So basically going from this brick to this brick, we're losing about 100 degrees, so it's transferring a ton of energy into all of these bricks. And like I was saying, we picked up about 150 bricks or more, and we basically put them in here and lit a small warm fire, not a hot fire like this one. And I basically dried all the bricks out. We still got steam rolling off certain spots here. I didn't want anything to blow up on me because it had too much moisture, but we kind of slowly baked all these bricks out. And I just stuck this little stick in here to keep all these from falling over there, because they're just kind of haphazardly stacked up. But the whole thing as a whole is very, very solid. All of this is very, very solid. This is not going anywhere. It's a nice solid back wall, a very, very good thermal heat sink. So I ended up routing this exhaust out of the sidewall where I had wood instead of where I had poly. So in order to get my stack out, I just went down here through the short wall and basically built a nice huge heat sink and basically insulated the whole backdrop. Everything's insulated very well behind the fireboard. That fireboard was reflecting a lot of heat also. I apologize, it's so loud. It's super windy and it's blowing all the noise off of that busy highway over there. So with all the weight of the stack outside the greenhouse, I ended up using a small little clamp on it, a nice clamp that's made for chimney stacks, just to hold it nice and secure because it's a very windy day and that thing is not moving. It's not gonna budge. So we have a good solid stack out there, and that is key. You don't want it falling apart in a snowstorm. Pieces are nice and secured. We screwed a whole bunch of stove screws into all of these pieces so nothing's coming apart and it is very secure. So I chose to go with clay bricks instead of concrete bricks because these are much more porous and they have little air pockets in them, and they are a much better thermal mass, and they hold the thermal mass longer and re-release it more steadily than concrete does. Now concrete or brick, they don't have very good insulation factors. They are not good insulators, but brick is way more conductive of heat and holding the heat as opposed to concrete because it is much more solid and it's much more dense. Because concrete blocks are usually just made of pure concrete or crushed sand or stone, and that makes a very, very dense block. Now your average red clay bricks have a combination of sand, lime, and concrete mixtures in them, leading them to be more porous and much better for thermal conductivity. The best part about using these clay bricks is that they can take the temperatures. They can handle up to 1800 degrees Fahrenheit without any problem. And then you've got fire bricks, which are specially made and specially formulated to have alumina in it, and that allows the brick to reach higher temperatures. You can put it in a 3000 degree furnace. Now clay bricks are hands down way better for what I'm trying to do here. I'm trying to build a large thermal mass around this and sink all of that heat into it, and I'm going to add a bunch more stuff onto this. Hence I've got a bunch of copper coil and I've got a few goodies underneath that. And all of these systems I'm going to add, and everything I've already added, are basically just building upon the thermal mass we are able to store overnight and into the night to be re-released in our greenhouse and keep at a decent temperature overnight. So that's basically the name of the game when you're growing in a cold climate. We have a double layer over this for good insulation value, 6 to 8 inches of dead air, and that really helps us out and keeps those cold temperatures out. But on a cold, cloudy day and you're not getting any solar activity, you're not going to have a whole lot coming from a John Payne system. It'll run sporadically. I mean, if you have it plugged into a live outlet or plugged into a drop cord, it's going to run flawlessly and you're going to have a lot of heat coming in. So you're either looking to store as much energy all day into the night to be re-released, or you're going to actively heat all the time and either have a furnace, a wood burning stove, a corn pellet stove, or some type of gas furnace where you're going to have to pay for the fuel constantly and have a bill every month. So I've gotten a few items for this stove already. I've ordered a few things as soon as I got the stove before I even lit the first fire. I had ordered myself this nice 100-foot roll of 1/4 inch copper tubing. And this is nice copper. I'm going to be able to wrap this around. This is going to be able to be reused over and over. So I got that 100 foot of copper tubing there, and that is going to go around the stove in some fashion. It could even just sit right on top and I can run water in and out of it, but I plan to wrap it around my actual exhaust stack. To go with that copper tubing, I had got myself another cheap little bilge pump. Now this has a pretty decent flow. I think it has a higher flow rating than the actual one I'm using for my John Payne, because we're only flowing about a gallon per minute or so through this system, maybe a little bit more. This one's saying that it's going to flow 600 gallons per hour, and that's what, 10 gallons a minute. That's going to be a lot of hot water going around and coming back out to be stored for the nighttime. Now I've shown this little steel tank here. This is like a 40-gallon steel tank. This used to be a water softener. So it's got 2 lines where I can actually screw right into the top, and I'm going to be able to run some water into this. I'm going to put fixtures on here, and then I should be able to store 40 gallons or so of hot water in this steel tank to be re-released at nighttime also. And that is part of this whole system. I got this thing for free, cleaned out the rosin in the bottom. It took me a few shots of water to actually fill it up and clean it out, but for the most part, this thing is 100% clean, no more sand, no more rosin in it. So it's ready to go for our purpose. And it's actually starting to dry out a bit here because it was sitting outside getting very, very damp. So I wanted to bring it in here and let it dry out and kind of get the fixture size. I got to figure out what kind of fittings I'm going to need up here to be able to actually screw in and connect my copper to both sides, because I actually plan on running the copper around the exhaust and filling it up into this tank and then overflowing it into my next tank, my Jean Pain heating tank. So if I'm putting warmer water into my Jean Pain tank, it's going to put warmer water through my floor and warmer water into my compost and possibly help it break down even better when we've got really, really cold temperatures. So I'm kind of pairing all of this together. I'm not forgetting about my compost heating because it got me through very, very hard and cold times. I'm really just going to be adding upon it and adding more heat to that system from an outside source here. So the next thing I got was a nice solar panel, and it came with everything I need to set that up. I'm gonna get my copper out of the way here. So we've got a nice solar panel kit. Came with everything I need. I got a solar controller, all the connections, all the wires, all that good stuff in there. And then we've got a nice new 100-watt solar panel ready for action. This solar panel is going to be to run this pump, and I ordered some more fans also. I'm going to be blowing all of the heat from this area throughout the entire greenhouse. So I got myself some more fans, like my geothermal fans, and I'm gonna rig up some type of bracket where I can mount them together and just basically circulate all the hot air that's rising off the stove through the other end of the greenhouse, because we're sitting about 70 degrees on this side of the greenhouse. It is very warm in here, and it is awesome because it's cold outside right now. It's probably not even above 30 degrees outside. Put my solar panel back over here. So we got all these connections with the solar panel, like the controller, the positive, negative wires, all that good stuff. Anything we needed is all in here, and it even comes with instructions that I might need to look at. So all of this energy is basically free energy. One-time investment on bricks, a stove, and piping. This is going to last us. We're not paying a bill to actually heat this greenhouse like with gas or any other type of fuel source. Using our wood chips and using scrap pieces of wood, which are very abundant, so it's not that hard to find enough stuff to burn this for a week at a time. And I've been accumulating a large load of scrap wood and offcuts and stuff like that for free. And I'm trying to get some type of system together where I can actually dry my wood chips outside or just keep them dry before I move them inside, because right now what is left of my wood chip pile is getting rained on and it's all starting to break down, and the smaller the material, the less time it has to burn in this fire. I plan on building some type of structure out of pallets just to keep my wood chips up off the ground on a nice piece of hardware cloth or some type of fencing to let air flow, and then I'll keep them layered where I can put more fencing and kind of keep layers and just try and keep all of those wood chips as dry as possible and keep them from composting and breaking down. So like I was saying with my Jean Pain tube here, this is running through my compost and warming up, and the other day it was blowing about 70 degrees out, but it's been pretty darn cold at nighttime, so I'm not sure what it's blowing right now. But I'm pushing that air through the bottom of all those base bricks beneath and behind our stove here. So with the new 12-volt waterproof DC fans that I got that are very high temperature running, they're safe to run around high temps because it'll be 200-300 degrees where they're going to be blowing air from. I plan on setting up some type of bricks. These are actually very warm. So if I can blow the air through all of these bricks, I should be in good shape to actually blow a lot of hot air to the other side of the greenhouse and keep it recirculating, as opposed to just warming this section up thermally and then it slowly transfers down. I want to be able to cycle this air and blow it off as fast as I possibly can. Now I spent another little chunk of money on one of those little Stirling engine fans. So it's just basically an eco fan. It runs off of the heat, doesn't need to be plugged in or anything. It'll just run directly on the top, and as soon as it heats up past 80 degrees, that little fan will start to spin. So I've got a lot of cool things coming, and I've only got about half of what I ordered right now. So I wanted to come out and show everybody this nice brick setup and why I'm using brick as opposed to concrete, and all of the plans I have going forward. So kind of as a wrap up here, We've been trying to heat this greenhouse as cheaply as we possibly can. We started by dumping free loads of wood chips, composting them, inoculating with nitrogen, and getting them real hot. So we are actually putting some decent heat. I just showed in the last video, we were blowing 80-some degree water out of there on a nice sunny day when the system was cranking and the sun was probably warming our compost up as well. And this John Payne heating system got us through that Arctic blast. I really wish I would have had this stove in place like this when that Arctic blast came through, because we would have probably not suffered as much. Some of the warmer or less cold hardy crops like our purple tat soy had definitely faded back and had some damage, but 99% of the greenhouse is still running strong. We have baby plants everywhere, everything's sprouting and continuing to grow right on through that polar vortex because of this John Payne heating system. So without this in place and without our second layer of poly having good insulation, we would be dead in the water. You have to have good insulation. You've got to have some type of heat source going, and if you're not going to have a heat source, you have to have the best insulation possible and a super passive solar approach. You want to use every ounce of energy that is coming from that sun when the sun is out, because half the time in the winter we don't see the sun for a week at a time. So relying on the heat from the sun is not always the best. That's why we've got all of our little heating systems down on the other side, so when it does get sunny, they all run on their own and they just kick on and they start heating that side of the greenhouse up and really boosting that heat from the sun, and that is their purpose down there. We've really only fired this stove up maybe a handful of times at the most, and that was all just purely experimental. We were trying to seal everything up and make sure everything was nice and tight, and just basically check for any leaks or any smoke leaks in here. And this has proven to be very efficient. With maybe 4 to 5 shovelfuls of wood chips, you get maybe 45 minutes to an hour, and that's like maybe a quarter to half of the way full of the actual pot belly. This was made for burning coal in originally, but you can throw all types of stuff in there. And I'm really interested next summer to get myself a nice supply. I want to try and make some molds so I can make up some of my own bio bricks from waste that we're not going to use and hard to get rid of, silage. Basically all the stuff that is hard to break down, like your corn stalks or your sunflower stalks. We grow a massive amount of sunflowers every summer, and we sell the flowers at our market and save all the seeds, feed our birds from them, feed our chickens and stuff. We even grow some that we eat for ourselves. There is a lot of waste from sunflowers. Those stalks are very slow to break down. So I'm thinking if we can get them before they actually start to dry out too much, I can run them through some type of shredder. I'm gonna buy myself a shredder just for this purpose of making these bio bricks. I think there might be a good source of untapped energy and wasted resource there. So if I can get them when they still have a little moisture to them, they can be molded very easily. I let them dry out, and then I can stack myself a couple hundred sunflower bio bricks in here and see how well they burn for me. I've seen a guy cutting mud bricks out of the wall on YouTube here, and he was basically just drying that mud out and he was burning it. He was burning the mud. I don't know if I'm going to be actually doing that, like a fire brick out of clay dirt. I mean, we have enough of it here, but the idea of burning our soil didn't really appeal to me. So I'm trying to use every resource that we have that is just a wasted resource, as opposed to taking from the land and burning it up. And we really probably won't even light this stove unless the temps outside are 15 degrees or lower, because our actual compost heating can really take those temperatures. This greenhouse is very sufficient and efficient, and we don't have any bills in here. This is all solar power, all free energy and free heat. So being able to put all of that to the floor, to the airspace, and into the greenhouse is very valuable in the winter time for us. So let's grab a few more temperatures here. I kind of wanted to check all this out and see how well it was working. My gloves are almost dry there. So this has been burning. I threw another little piece of wood in there, but for the most part, a lot of the stuff has burnt down. Not a very big fire in there. All of our bricks, 160, 170, 140, 150, 160, about 100 degrees down here, 110. So coming to the outside, these bricks on the outside are sitting about 60 degrees furthest away from the burn pit. So coming up, all of these bricks on the outside have raised temperatures quite a darn bit. They're holding about 90 degrees on the whole outside of this wall here, 100 degrees. So these bricks are very warm, See down here, the bricks down here have not warmed up quite as much. They were about 45, picked up about 5 degrees, but this is only about an hour and a half after burning. I've been talking to you guys for about a half an hour or so, and all of this has basically dissipated heat and dissipated into all of these bricks. So the stack is still sitting about 300 some degrees. These bricks right here are 150, all the way out to the outer brick is about 90 degrees. So that is very, very cool stuff. Basically all the way out, 4 bricks out, it's about 90 degrees. Let's jump down here and kind of check these temps there. This side has not transferred the heat very well through because these bricks are much more solid than these bricks with the air gap in them. But these are going to hold a lot of heat for us. Once these bricks get warmed up, like this brick here that's basically 90 degrees solid all the way through, then you can see how close it is to the plate. That is a very solid brick, and this has only been going for maybe an hour, hour and a half. It feels very warm. Very, very cool to have this nice thermal mass, and for dirt cheap also. All of this is as cheap as I could possibly do it. I've still got a lot to do to this and a lot of experimenting to do with this actual stove here. I want to see what kind of wood chip burn I get on a full wood chip where I fill the whole thing up with wood chips and let it go. I want to try and get those as dry as possible, obviously, and I want to try using some wood pellets. I know those cost money, but I want to see if I can burn some wood pellets in there, or possibly even corn, and I'm going to pick up as much scrap wood as I possibly can. I wanted to run down here and check the middle thermometer, sitting above 60 degrees, about 65. So we're sitting 65 in the middle of the greenhouse. It feels physically warm in here. It's pretty darn cool to have that little stove going. And by the door here, we're sitting about 50. So that came up from where it was at about 45, and our door is not all the way sealed. It seals better when I'm outside pushing it as opposed to just pulling it closed. I've got to do a little work with that because I got to get it sealed up better. And I had a great comment that I should have a double door system where I'm not exiting all the air from the greenhouse at one time. If I can have a double door type system with a little extension out there, maybe like a 2-foot extension, like a little breezeway or doggy door type thing, where it's a double door and I save all that heat from rushing out, especially on a cold, cloudy day like this, where we're putting a lot of heat in and all of that heat wants to escape. As soon as you open that door, the cold air will rush right in. So I think this video is getting a little long here. I'm going to cut, and I'm going to basically start doing a little work with all this, and I'll bring some more updates with all the systems as I piece them together. And once again, thank you to all my subscribers. You guys are awesome. You guys helped me work through this in a sense. I got a lot of information, I got a lot of ideas, and a lot of feedback from you guys. So I really appreciate that, and keep it up.